So today we will study about equilibrium. Right. So this will be the part one of the equilibrium. Part one of equilibrium. Right. So first question. Now look at the first question. It is hydrolysis of sucrose. It is talking about sucrose hydrolysis. Sucrose hydrolysis. So when sucrose react with water, so sucrose general formula is it is C6H12O6. Right, it reacts with water to give out the glucose and fructose. So sucrose formula will be this is for fructose, right? So it will be double of this one. So this is not sucrose. C12H22O11 is sucrose. So this is your sucrose. When dissolved in water, it produces glucose and fructose. Glucose plus fructose. Right. If the equilibrium constant is given, so for this reaction, equilibrium constant is given 2 into 10 raised to 13. Right. At temperature 800 Kelvin. The value of delta G. So you have to find the Gibbs free energy relation. As we know, delta G is equal to delta G naught plus RT ln of Q. Q is nothing but it is reaction quotient. Q is reaction quotient. RT, R is your gas constant and T is your temperature, right? And delta G naught is a standard Gibbs free energy. A standard Gibbs free energy, right? And delta G is Gibbs free energy only. Gibbs free energy, right? So this is the delta G is equal to delta G naught plus RT ln of Q, right? So at equilibrium, what happened? At equilibrium, delta G is equal to 0. So formula will become delta G naught is equal to minus RT ln of K equilibrium. Understood? Now put the value, then you will get the delta G naught. So delta G naught is equal to minus R is what? It is 8.314. That is gas constant. And T is your temperature. That is 300. Right? Ln of equilibrium constant is given. This is your equilibrium constant given. Right? This is your temperature given. So this will be 2 into 10 raised to 13. So what will be the answer after calculation? It will be the first option. Right. So you have to write the answer in this form only. Right. So this is your answer. No need to calculate. You can look at the option. So it is matching with the D option. So please remember the formula for a standard Gibbs free energy, how it is related with equilibrium constant. Now look at the next sum, second question. So second question is pH of saturated solution. So it is talking about pH means power of hydrogen of saturated solution. So compound is calcium hydroxide CaOH2 and its pH is already given, that is equal to 9. The solubility constant. So you have to find the solubility constant of this reaction. Solubility constant. Right. So it is talking about solubility constant asked in 2019. So see how it is related with pH. So when calcium carbonate dissociate, it produce Ca2 plus, Ca2 plus plus 2 OH minus, right? So pH is equal to 9 given, and we know the relation between pH and pOH is equal to 14. So it is 9 plus pOH is equal to 14. pOH is equal to 14 minus 9. So it is equal to how much? It is 5. So we are getting the power of hydroxyl is 5. Right. So we know the solubility constant, that is Ksp is equal to Ca2 plus concentration into concentration of OH minus raised to 2. Why it is 2? Because its coefficient is here 2. This one. That's why we are writing here. For calcium it is 1 and for OH minus it is 2, right? So it will become then S raised to 1 and it will be 2S raised to 2. So it will be equal to 4S cube, right? 4 square it is 4 and S into S square it is 4S cube. So now put the value. So it will be 4 into OH concentration, we know. This is the OH minus concentration. So it will be 10 raised to minus of 5. Right? Why it is so? Let me explain. pOH is equal to minus log of OH minus concentration. It is 5 here. It is equal to minus log of 10 raised to minus 5. So here it is 10, right? We take this minus on this side. So it will be minus 5 log of 10 concentration of OH minus, right? So it will be 10 raised to minus 5 of OH minus concentration, right? So that's why I'm putting here 10 raised to minus 5, right? And it is of 2 times, right? So it will become then 10 raised to minus 5 by 2 raised to 3. So calculate it, you will get 0.5, 10 raised to minus 15. So this formula you should know how to write it. And pH formula we should remember this one. Right. So main point is here. And this relation should be known to you, right? Summation of pH plus pOH is equal to 14. And this is the ion equilibrium equation you should write here. So please write this equation asked in 2019. There is 1 point remain, right? So it is 2 OH minus, right? So OH minus value we know, right? That is 10 raised to minus 5, right? And for 2H minus, so its concentration will be half of that. That's why we have divided by it is 2. Right. Now see the next sum. Now next sum is question number 3. So which one of the following condition will favor maximum formation of the product? So it is question number 3. It is A2 plus B2. Right. And forming it is X2. So delta H of this reaction is given, that is minus X kilojoule. Right. So which of the following condition will favor maximum formation of the product? Right. So it is asked in 2018. So for this reaction, on increasing the pressure, equilibrium shift in a direction where number of moles decreases. Right. So you can count. This is your reactant and this is your product. So this is 1 mole, this is 1 mole. Right. So moles of reactant is 2. Moles of product is 1. So on increasing pressure, when we increase your pressure, right, so equilibrium shift in the direction where number of moles decreases. So for equilibrium shifted where number of moles is less, so it will shift it towards the product side. So right, so it will be shifted towards the product, shifted towards product side, right? Therefore on decreasing temperature, equilibrium shift in exothermic reaction. On decreasing temperature, when temperature becomes lesser, the equilibrium shifted in exothermic reaction. Equilibrium shift in exothermic reaction. Exothermic reaction. Right. So forward reaction will be favored. Right. So for low temperature, forward reactions would be favored. So higher pressure and lower temperature favors the maximum formation of the products. So both condition will favor the forward reaction. So write this one. There is there. Yes, is there. Take from there. Now look at the next term. Next term is fourth one. So fourth one is talking about a 20-liter container. So volume is how much given? 20 liter. Right. So temperature is 400 Kelvin. Contains CO2 gas. CO2 gas at pressure. P equal to 0.4 atm. Right. Excess of strontium oxide. Strontium oxide. The volume of container is now decreased by moving the movable piston in the container. The maximum volume of container when pressure of CO2 attained its maximum. So when strontium carbonate dissociate, it forms strontium oxide and CO2. So Kp for this reaction is given 1.6 atm, right? So it is asked in 2017. So let's see how to solve this one. Right. So for Kp for this reaction is given pressure of CO2. It is 1.6 atm, atmospheric pressure. So V2 will be equal to nRT upon P2. This is ideal gas equation. PV equal to nRT, right? So we have to find P. So I have put here P2 and this is your V2. So we have got V2 now after putting the value. So P2 will be equal to how much? This is nRT by P2. Now put the value, you will get the value V2. So it is 0.4 into 20 divided by how much? By RT. We are finding just number of moles. Right. So this is your equation 1, this one, and this one is your second. So now from 1 and 2, what you get? Right. So in V2, see, V2 is nothing but it is nRT by P2. Instead of n, what we can put, it is 0.4 into 20 upon RT and write the remaining part also. So it is RT upon P2. Right. Now cancel the parts which is getting cancelled by this numerical part. Right. So this is P2. P2 value we know 1.6. Right. So it will be 0.4 into 20 upon 1.6. So it will be how much? It is 5 liter. So for volume 2 we are getting as 5 liter. So please write this one. Now look at the question number 5. So which of the following statement is correct for the reversible process in a state of equilibrium? So it is talking about reversible reaction. Reversible reaction, right? In a state of equilibrium. State of equilibrium. So see for the mathematical expression for the equilibrium, how it is related with the standard Gibbs free energy. So it is given by delta G is equal to delta G naught plus this is your G naught plus 2.303 RT log of Q, right? So when log Q is uh, converted into 2.303 log of K equilibrium, so this is the relation between that. So for equilibrium condition at equilibrium, delta G becomes 0. So delta G is equal to 0. So formula will become delta G naught is equal to minus 2.303 RT log of, instead of Q we write K equilibrium. So it will become K equilibrium. Now put the value. So it is nothing but delta G naught is equal to minus 2.303 RT log of K equilibrium. So formula will be reduced to this point. So please match this formula. From which option it is matching? It is matching with the first option, right? So it will be the answer will be first option. Now look at the question number 6. So for general equation, so question is, if the equilibrium constant for a reaction is given, Kp for the equilibrium is given, that is 1.6 10 raised to 12. Then the equilibrium system will be, it is asked in 2015. So how it is related, please see. General equation for the equation is, so it is A of A plus B of B produce C of C plus D of D, right? So these are reactant, this is the product, right? So capital A and B are is your reactant, and C and D are your product, right? So equilibrium constant is written as concentration of C raised to C, concentration of D raised to D divided by concentration of A raised to A, concentration of B raised to B. So this is the equilibrium condition for the given equation. So higher the value of equilibrium constant for a reaction, more will be the concentration of product, right? So you can see here, this equilibrium constant is directly proportional to concentration of product. So equilibrium constant increases and this concentration of product. Upper part is concentration of product and lower part is concentration of your reactant, right? So for getting the equilibrium constant maximum value, concentration product should be maximum, right? So this should be the condition. So now see, it is 1.6 10 raised to 12 value is given. So the reaction mixture contain mostly products, right? Because this value is very high, very large. So product will be large. Product will be large. Now look at the question number 7. So it is nitrogen. So nitrogen plus oxygen produce 2NO. So for this reaction equilibrium constant is given K, right? For the next reaction like 2N2 plus half O2 produce NO, right? So what will be the equilibrium constant for this one? So C for the first reaction, equilibrium constant can be written as concentration of NO raised to 2 divided by concentration of N2 into concentration of O2. So this is the equilibrium constant for the first reaction, right? Now write equilibrium constant for this one. Suppose I am writing K1. So it will be concentration of NO divided by concentration of N2 raised to half, concentration of O2 raised to half, right? So how you will get this one, second equation? So by taking the square root of the first equation. So take a square root of first equation, right? Then it will become root of K equal to, this under root will be removed. So it will be N naught divided by N2 raised to half, O2 raised to half. So you can see from the equation 2, right hand side is matching. So this part is matching, right? This part. So instead of this one, I can write K. So under root of K is equal to K1. So this will be the answer for that one, right? It is asked in 2014. 2014. So please write this one. And under root of K can be written as K raised to half also. So K1 is equal to K raised to half. So this will be the answer for that. Now look at the question number 8. So it is talking about when nitrogen react with 3 moles of hydrogen, it produces 2NH3, right? Plus heat. So the equilibrium shift in forward direction. For shifting the forward direction, shift forward direction. So what should we do? It is asked in 2014. So according to Lee Chartier principle, right? So there is a scientist which have talked about it. So it is Lee Chartier principle. This is Le Chartier principle. The equilibrium shift in that direction so as to oppose the applied change, right? So equilibrium is shifted towards that direction. There is oppose applied force, right? Applied force. This is talking about equilibrium shift, right? So if the concentration of ammonia increases, this value increases. The equilibrium shift in the backward direction to oppose the increase in the concentration, right? So see the condition when we increase this concentration, product concentration, so it will be shifted towards the back side. So this is the backward reaction favored, right? So in which there are more number of gaseous molecules are present, thus it also shift in the backward direction. There are four gas phase molecules. So this is 1 molecules of nitrogen and this is the 3 moles of hydrogen gas, right? 2 moles in the product side. If the concentration of N2H2 decreases, right, then the equilibrium shift in the backward direction to increase the concentration of reactant. So what happened if the concentration of N2 and H2 decreases? So see, N2 and H2 value decreases. So what happens? So this will be the backward direction, it will be favored, right? If the pressure increase, it is talking about, here it is talked about concentration. Now here it is talking about pressure P. If the pressure is increased, the equilibrium shift to the side where lower number of gas molecules are present, right? So when we increase the pressure, so less it goes to the less number of moles, right? So more product will be formed. So forward direction. Now take, let's talk about the temperature. When temperature is increase, or first talk about the decreasing. So when temperature is decreases, the heat evolved in the reaction is consumed. So what will happen? Heat will be evolved, right? And reaction move towards the forward direction. So more NH3 will be formed. So this is talking about Le-Chartier principle. So it first talk about the equilibrium, second concentration, third one is pressure, then is the temperature. So these are the four conditions which is given by the Le-Chartier principle. So please write this one important points.